All right, here we're on the second end, the last part of 2.7. And here, this is where we're going to deal with the vertex form of the quadratic. Our goal here is to graph quadratic functions in vertex form. So vertex form, as a fun, friendly reminder, is f of x equals a times x minus h squared plus k. And what's really nice is that whenever I'm in this form, I can just simply look. Here's the x and here's the y coordinate of the vertex. It's always going to be in the form of h comma k. Now notice something. I want you to pay close attention. This says x minus h. So it's always going to be the opposite of what it looks like for my vertex. So if this says x minus 3, then h is going to be 3. If this says x plus 1, then this is going to be a negative 1. So pay close attention to this x minus h part. Now, plus k, it means the same as k. So if this says plus 4, well, this is going to be a 4. If this says minus 7, this is going to be a negative 7. So it's the opposite of what you think on the inside and the same as what you think on the outside. Again, we'll get to an example here in a minute, but I want to make sure you see that. Well, the steps are going to be really similar to what we did in standard form, except for things are going to be much easier. All right, so the first thing we want to do is we want to find the vertex. And that's going to be exponentially easier than the last time. Here, the vertex is simply h comma k. And then the second thing we want to do is our table of values, our quick table of values. Now, this might be a little bit more difficult, only because we have to handle the parentheses first, and then we'll go from there. But that table of values, again, I want to put my, that's x and y. We say one thing, write another, am I right? All right, so down here we get our h and our k, and we're going to go 2 to the left and 2 to the right of h, whatever the vertex is. And for step 3, we are going to plot and graph. Now, what's going to be a little bit different this time is that I definitely want to discuss what's going to be a max and what is a min. So, what's the max or min? If I have a parabola that opens down, if I have a parabola that opens down, this is going to be a max. If we have a parabola that opens up, here, this would be the vertex, would be a min, a minimum value. Another thing that we're definitely going to take a look at with this is the axis of symmetry. Again, I can't make it any easier than x equals h. So whatever you find out to h to be, x is going to equal that number is going to be your axis of symmetry. All right, and that's the line that goes right through the parabola. All right, it's the one that cuts it exactly in half and creates symmetry on both sides of that line. Now, it's not something that you necessarily graph, and it's not something that you see. It's an imaginary line in which the graph is symmetric. One other thing that we're going to do is in this, little chunk, we're also going to take a look at what happens if I start with a graph. How could I rewrite that graph? Just take the information from the graph, and how could I write a function from that? So pay attention to what we do forwards, because in this one, we're going to do it backwards as well. So let's go ahead and get started with our first example. Here we have f of x equals 2 times x minus 2 squared plus 5. And my vertex, this one's going to be nice and easy. I have x minus 2, looks like a negative 2 in here, but it's really a positive 2 for the vertex. It looks like a positive 5, and it's really a positive 5 for the y-coordinate. So the vertex in this one is a 2, 5. Now I want to go ahead and create my table of values, x and y. I want to put 2, 5 in the middle, and then here's 2. The 2 to the left are going to be 1 and 0, so I want to put 1 and 0. 2 to the right are going to be 3 and 4. 3 and 4. Again, I want to use the numbers that are going to be the easiest to use here. So I'm going to plug in 1 and 0 and see what happens. So f of 1 is going to be 2 times 1 minus 2 squared plus 5, which is 2 times, well, 1 minus 2 is negative 1 squared plus 5, and negative 1 squared is a positive 1, so 2 times 1 plus 5. 2 times 1 is just 2, and 2 plus 5 is 7. So here I would have a 7. Now let's plug in a 0 and see what happens. So f of 0 is 2 times 0 minus 2 squared plus 5. 0 minus 2 is negative 2. Negative 2 squared is 4, so 2 times 4 plus 5. 4 times 2 is 8. 8 plus 5 is 13, so I get a 13 up here. And if I plugged a 3 in, I would get a 7 out. If I plugged a 4 in, I'd get a 13 out. Thank you, Symmetry. I appreciate you cutting my work in half. All right, so now all we have to do is plot these points. All right, so 2, 5, and I'm going to use my orange again. I really like this color. So I'll go 2, 1, 2, 3, 4, 5. So the point 2, 5 is going to be here. 1, 7. 0, 13 is way off the map. 3, 7, and 4, 13 is way off the map. But I get the ones that I can, and we're golden. Now, the A value was positive, so it definitely opened up. And here, in this instance, we are going to have a minimum value. So this is a minimum value. It's an arrow pointing to the vertex that this is a minimum. And I can also state that my axis of symmetry is going to be the line x equals h. What's h? H is 2, so I get a 2. And that's as easy as it gets. I cannot stress that vertex form is the best form to graph in. Very, very nice. It's very friendly. Now let's take a look at what happens if we try and go backwards. My directions here are pretty simple. Write the function. Well, I know that the function is going to be in the form of f of x equals a times x minus h quantity squared plus k. So there's really several things that are at work here. Remember, f of x is the same thing as y, so that's just a friendly little reminder. I have y, a, x, h, and k. I have 1, 2, 3, 4, 5 things that I need to try and take a look at. In general, when I write my function f of x and x, I don't need to worry about it. Those aren't numbers. It's always going to be f of x equals something in terms of x. So what I really need to focus my attention to is a, h, and k. I need to find a, h, and k. All right, so what's really nice is that h and k are my vertex. Well, here's my vertex, and that's the point 3, 2. What's really nice, so now I have f of x equals a times x, and this is a positive 3, so x minus 3 squared plus k, and that's a positive 2. Well, now I've already handled h and k, so now the only thing really left over is this a. I need to go find a. So in order to find a, I need a second point. And the second point on here is this point that they're going to tell us, and this is the point right here. This is the point 1, 1. And this is where x equals 1 and y equals 1. So instead of f of x, I'm going to replace it with the value of 1. And I have a. And instead of x, I'm going to replace it with the value 1. And then minus 3 squared plus 2. All right, so now all I have to do is solve for a. Once I solve for a, then I will have my whole function, and I can write everything in the form of f of x equals. Okay, so I'm going to do a couple of things on this first step. I'm going to subtract 2 from both sides, and I'll end up with negative 1. And 1 minus 3 is negative 2. Negative 2 squared is a positive 4. And I don't want to write A4. That looks weird. So I'm going to write it as 4A. And now I can divide by 4. And clearly now I get A equals negative 1 over 4. Take my A, and I'm going to plug it right back here. So now the function f of x equals, A is negative 1/4, x minus 3 squared plus 2. I'm going to try and make this a little bit simpler, and maybe if I could give you a couple of steps to follow. Number one, I need to find h and k, right? Hello, that's my vertex. That's the easy point to find. And number two, I'm going to use a second xy point to find a. So we're going to find our h and k. We're going to plug that into our h and our k. Then I'm going to use a second point, replacing my x and my y. And then I'm going to simplify and solve for a. Once I have h, k, and a, then I can write my function.